Start the recording. Share the application screen.
Actually, I went back into the recording yesterday.
What's that?
I went back into your recording yesterday.
Okay, good.
Yeah.
All right. So, first of all, the formula. Oh, that's the wrong formula. Do I have it? These are all stats. Let me see something here.
Yep. Are you taking pictures? Yes, me too.
Let's see, do I have?
I think it's like July or something. Is it July or maybe later than that, October, I'm not sure.
These are all stats, unfortunately. Okay, so. My bad. All right, so I guess you can just look at the handout. It's the one I handed out yesterday.
Okay.
The very first formula. Real quick. We know that I equals PRT. Once we solve for I, then we know that A equals P plus I. Well, let's see, how can I say this? If I call this A1, P1, I1, then for I2, we have P2 R T2. And P2, oops, yeah, A2 is P2 plus I2. But, let's see, how do I want to say this? I lost my train of thought. I want to make it easy. I don't want to get too confusing for you. Let me start over. We know that I, P, R, T, A, P, plus I. Well, this is 1. For 2, I would have P2 plus I2, but I2 is PRT. And it turns out that P is constant. I don't really have to annotate that because it doesn't change. I just added at the beginning, so it's always there. I don't add to it. But what's going to change, R is not going to change. The time might change. But notice that from here I can factor out a 1 plus RT. Right? So A2 is P times 1 plus RT. Instead of just P plus I, because I'm adding on, this is I. I think I'm confusing myself too. Let's just drop the subscript, so let's just do it this way. Let's just do it this way. I think this will be easier if I just do it this way. If I factor out the P, I get 1 plus RT, right? Factor out a P from both of these. From here, I have a placeholder. I have a 1. Because if I distribute it back, I get this back, right? P plus PRT. Follow? Mm-hmm. Okay, so this is for the first year. Now for the second year, I have P times 1 plus RT plus I. But I is simply PRT, which is P times 1 plus RT times RT. See, in other words, P is now this, because it's got interest. And now for the second year, when I factor out, this is constant for both of them, so I have P times 1 plus RT times 1 plus RT. So it equals P times 1 plus RT squared. That's if I just did interest once a year at the end of the year. So, in other words, the principal stays the same, but what happens is I get another factor of interest. And so I'm getting interest on interest. You see, that's the idea of compounding. And this is just if I did it at the end of 1 year. So by analogy, you can see that for the third year, it would be RT cubed. Now, what happens with compounding is, what if I only use like half a year? What if I did it every 6 months? Then I couldn't use all of R. In other words, I would only be R over 2, right? Because well, not R, but T over 2, 6 months. If I did it every 6 months. So that would be the interest for 6 months, and my future value after 6 months would be this. And now when I factored out the P, I would have T over 2. And if I did it again after 6 months, it would still be T over 2. And now I would have T over 2 everywhere. I would have T over 2 squared. But instead of T over 2, it doesn't matter where the 2 goes. It's essentially over the R. And that's what we do. We take 1 plus R and divide by the number of times we compound every year, and times T. I'm sorry, not T. T is up here, becomes MT. So this is the form. This formula becomes this. The only difference here is that here N is 1, because I'm only compounding once a year. So if I had a 1 there, it wouldn't matter. See that? In other words, if I only compound once a year, N is 1. N is the number of compoundings per year. So what happens here is, if I compound, let's say, every quarter, then I only use 1/4 of the interest every quarter, but I have 4 quarters per year. So T is the number of years. If N is 4, then I get an exponent of 4 for each year, a multiple of 4. So that's why this is slightly different than when we had a whole numbers. But this is the formula for compound interest. The only difference is, well, we have R over N instead of just R. And you'll see R over N a lot, and NT also. NT is the number of compoundings for the whole period, for the whole time period. So that's the formula. That's basically where it comes from. The algebra can get really deep. I think that's a pretty good explanation as far as it goes. But so what we do here then for the problem, all I use is a calculator, and if you follow the calculator formula, they want P is 2,000, so I just put 2,000, and it's 1 plus R over N, so R is 8%, and I'm only going to use semi-annually, so I'm only going to use half of that. I can only use half the interest because it's an annual interest, and then the exponent is NT because there's 2 6-month periods per year, and it's 3 years. So the exponent becomes 6 because I'm going to compound it 6 times. If I do it every 6 months, then there's six compoundings over 3 years. That's where the 6 comes from, NT. And for each compounding, I only use half the interest. So when I'm done, I have $530.64 interest. So the total amount in the account, that's the future value, would be 2530.64. And then they're going to ask me how much of that is interest. So just subtract the 2,000, so it's $530.64. Now, if I just did 8% for each year, and don't worry about compounding, if I just said I got 8% per year, 8% of 2,000 is $160. Times 3 years is 480, right? If I just did 8% times 2,000 times 3 years, the simple interest that the minimum simple interest would be $480. But you see, I get an extra $50.64 because I'm compounding 6 times. I'm getting interest on interest, right? Because see, at the end of 6 months, watch, if I did 2,000 times 8% times half a year, which would be 6 divided by 12, 6 months over. See, I get $80. I do get the $80 that I would have expected. Because if I'm getting 160 for the year, I can expect to get 80 for the 6 months. But at the end of the 6 months, my principal is no longer 2,000. At the end of the year, for the next 6-month period, it's 2,080. So I'm going to get interest on that. See, I get it's still 6 months. So what I'm doing here is I'm doing the simple interest for every 6 months. See, now I get $3.20 extra. So at the end of the first year, instead of having 160 in simple interest, I have $163.20 in compound interest. So that's how it works. So I would add the $3 or the 83.20 to the 2,080. So at the start of the second year, I would now have $2,163.20. I've gained $3.20 for the year by compounding. Now, that doesn't seem like a lot, but you can see over the space of 3 years, it worked out to be $50.64 beyond what the simple interest would be. Let's see if we can figure that out as simple interest. Let's do it this way. If I had $2,000, if we just use the simple interest formula we had before of 8% and then 3 years, yeah, 480. That's simple interest, right? But you see, we gained $50.64 because we compounded the interest. We calculated it every 6 months. As long as we left it in there for 6 months, they gave us the interest at that point, and we didn't move it. We left it. So they don't give us interest on the 2,000. They give us interest on the 2,000 plus whatever interest is already in there. That's what compounding does.
I did not know about that.
What's that?
I've never heard of compound interest.
No, but that's what it does. That's why it's really important. It's a modern miracle, actually, and a lot of people feel that way. All right, so the formula is straight up. It's real simple. So here's P is 3,500, 3 years at 6% compounded quarterly. The number you have to figure out now is N. N equals the number of compoundings per year. So if it's quarterly, then N is 4. If it's monthly, N is 12. If it's weekly, N is 52. And if it's daily, N is 360. It's not 365. There's also, have you ever heard of, what's it called? Continuous interest. Compounding continuously. Banks used to advertise that. It might come back into style. Because there's a limit. Because as N gets huge, this goes to 0. Right? The bigger N gets, if I'm compounding continuously, let's say I compound every second. this gets to be a huge number, so the amount of interest is infinitesimal, but this gets huge. Well, there's a limiting value on it. It's the limit of 1 plus r over to the nt is e. The e is a not a complex, irrational number like I, not a pi, like pi.
Okay.
It's a naturally occurring number. It comes up in engineering an awful lot, in engineering applications. Strength of materials and whatnot. And what happens is A is equal to PE to the RT. This formula becomes this. It's called continuous compounding. It's the absolute upper limit that you could get for interest. Maybe we'll have an example before we're done. I'll show you how that works. But it's a gimmick. Because I was a kid, they used to advertise it. Continuous. And I was a little kid, I go, what do they got, squirrels in there just constantly? Anyway, so now we got 3,500 parentheses 1 plus r over n, so 0.06, and we said n was 4 because it's quarterly, and then it's nt, so it's 4 times 3, so there's 12 compoundings for the entire run of the saving. So we would end up with $4,184.66. And they want the amount of interest. So subtract 3,500, $684.66. So once again, the simple interest would have been 3,500 times 6% times 3 years. So you see we've made $54.66 beyond the simple interest. You can imagine if when you start adding zeros to the amount you started with, it starts growing rather quickly. Plus 6% is a good interest. And 3 years is a short time. The longer you leave something, the more you can expect. So maybe this is a good time to show you, let's do this. Let's take something really straight up, like $1,000 at 5%. And we'll do it yearly. That's just simple interest. Caret 1. 1 compounding, $50. What if we did it twice a year? That would be 1 plus r over n caret 2, because there's 2 compoundings per year. See, I get an extra 63 cents. Now let's do it quarterly. So now I'm dividing by 4, and the exponent becomes 4 because there's 4 quarters. I'm only doing it for 1 year, just to show you the difference. So now I got 95 cents extra. So now let's do it weekly. So second enter, okay, 12 caret 12. So now I got $1.16 extra. Now let's do it weekly. So that becomes 52. So I do it for 52 compoundings. So now I got $1.25 more. So you see it grows a little bit. This is just a flat example. Let's do it every day. So let's do 360. So that'll be 360 caret 360. So now we got $1.20. See, it's not a lot. And then if I put that formula in there, if I do 1,000, I do E to the RT, 0.05 times 1. We don't have to do that. See, there's the absolute limit. $1.27 extra interest is all. That's why you'll see people advertise it. It's a gimmick because they know they're only giving away a few extra pennies over quarterly or daily or whatever. It's an advertising thing. Just because banks want to get your money, they'll give extra money to get more money. They figure that in the long run. But this is how the compound interest works. So let's keep going here. Number 11. 8,000, 2 years, 5.5% compounded monthly. So 8,000, parentheses, 1 plus R over N. That's always it's always going to be part of the formula, R over N. And it's monthly, so it's 12. And then the caret, 2 years, so it's caret 24, 2 times 12. Is that okay if I just do that?
Mm-hmm.
Okay, so $8,927.98. So we got, wrong button. We got $927.98 interest. Let's see. Number 16. I think we're going to change it up slightly here. Yeah. So this is called the future value formula, by the way, because we're solving for the future value or the accumulated value. I like future value. I think it's a better, except it begins with the word A or the letter A. So now, what if I say I want this much money at some point in time after T years at this rate compounded according to a schedule? How much money do I need now? Well, if I just divide both sides of the equation by this thing, guess what? I get P equals A divided by 1 plus R over N to the NT. So that's the second formula on the page. It's called the present value formula. So if you know how much you want, and you know the schedule, and the time period, and the rate, then you can figure out what you need to put in today to get that amount. So that's on the second line. It's called present value formula. So here's what they're asking. They want to know how much do I have to put in now if I want to make 95 grand in 14 years at 5%. So that 95,000 goes in the numerator, A, and then I divide by, it's a double parentheses, 1 plus R over N, which is 0.05, and it's compounded semi-annually, so it's N is 2. So I divide it by 2, and then caret, the exponent's 14 times 2, right? 28 parentheses. So I need $47,583.39 right now. 47,583.39. It's about double. I need about half the money. Half the money would have been 47.5, right? Or no, 42.5. No, wait a minute. 47.5 would be right, yeah. So I need about half the money right now, and in 14 years it'll double. Okay. That's amazing. There's a rule of 70. You guys ever heard of the rule of 70? It's the rule of 70 or rule of, if you take the interest divided into 70, it tells you how long it'll take to double. And 14 times 5 is 70. This one's just about spot on. Okay, so you can see, if I know I want 95 grand and I got 14 years to do it and I know I'm getting 5%, what do I need today? So I get all my money together, I get together $47,500, put it in an account and just leave it there, and then I'll have that much money if I want to wait 14 years.
Yeah.
Well, for individual situations, it's not a useful calculation or idea, for that matter. But for corporations, businesses, municipalities, somebody who knows they're going to just leave it sit and pay off some debt. Governments. All right, let's try another one of these, 17. You want to accumulate 120 grand after 3 years. So this one's going to be a little bit higher because only have 3 years to get it. So we put A as 120,000 and divided by double parentheses 1 plus R over M. So it's 0.07 quarterly would be divided by 4 caret 12, right? 3 times 4. And T is 12. So we've got to put 97 grand in some right now. So I hope putting the formulas in this style helps you when you put them in the calculator. I pretty much have them memorized just because I use them all the time. Let's see, 21, let's see what, I think 21 we kind of review. We go back to future value, yeah. To help pay for new costumes for a play, the theater invests $1,600 in a 42-month CD, paying 2.2% compounded monthly. Determine the amount the theater will receive when it cashes in the CD after 42 months. So this is more realistic, right? So this is a future value. We're going to invest $1,600. So 1 plus R is 0.022, and it's monthly, so divided by 12. And I don't have to use NT. They told me what NT is. It's 42 months, so it's just caret 42. Well, it says 42 months.
Right.
So the number of compoundings is what goes in the exponent, so that's 42. So we'll have $1,727.95. That's a little more realistic in the sense that you could see somebody leaving something for 3.5 years or so. Of course, they only get a little bit, $1,027 or 1,100. No, they only got $127. What am I thinking of? Of course, that's because the percentage is 2.2%. It's real low, which is kind of realistic for modern times, actually. It's hard to get good interest rates right now. Everything's so bizarre. All right, Karen invested 11 grand at 1.75% compounded semi-annually. 4 years later, she withdrew the full amount to put down as a down payment on a new house. So this is realistic. It's a low percentage though, but so that's how it goes. 11,000. You'd think for 11,000 she'd get a higher rate, but apparently she didn't do her homework. And it was semi-annually, so divided by 2, not 22. And it's for 4 years, so caret 8 compoundings. So she would have gained $794. 11,794 and no cents. Okay. So that's it for those two formulas. Those were the examples we have. We will see these at some point in other uses, or their ideas of surrounding them. Next, we want to go to what we call APY. So let me tell you that APY, I think I mentioned it yesterday. APY is the percentage that we would get if we just compounded once but had the same interest. So it's the effective annual yield, which is also called annual percentage yield, APY, that's where it comes from. It's also called effective annual yield. It's the simple interest rate that gives the same amount of interest as a compound interest rate over the same period of time. And it's real easy to calculate. Let's see, we got to go to 29. It's too slow. I'll go this way. he says. Famous last words, 29. All we have to do is use a principal of $1, and that'll give us the APY. See, that's what they even do here. They say, determine the effective annual yield, the APY, for $1 invested at 1 year at 5.9% compounded semi-annually. So I use the same future value formula, only I put a 1 in front for P, so we don't really got to put anything there. So it's 1 plus R, which is 0.059, and it's compounded semi-annually, and it's caret 1, because it's just for 1 year. I'm sorry, caret 2, because it's compounded semi-annually, so caret 2. So you can see that we got our dollar back. So there's our principal, and there's our interest. We would round it off to 6% interest, but as a percent, it's 5.99. So we actually, the APY is 5.99 to the nearest 100%. You see that? If I round that decimal, we get 5.99%. Just eliminate the 1 because the 1 is the principal. Right, that's the principal. So there's the effective rate. And so it's 5.99, 2 decimal places. So that's what they would advertise. They would say 5.9 APR, 5.99 APY, and be in bigger letters because it's a bigger number. And they're not lying. It's just that you only get that if you leave it in there for the full year. Okay. So what that means is you got your extra compounding. That's what it amounts to. But it's what's the percent if you just do it if you did it for one time. That's how we figure it out. We'll do another one here, or another couple of examples. So Bank A advertises a money market that pays 2.4% compounded quarterly. That's N equals 4. And Bank B advertises a money market account that pays 2.3% compounded daily. Determine both of their APYs. All right, so the first for A, it's 1 plus 0.024, and it's compounded quarterly. So divided by 4, caret 4. So it'd be 2.42 to 2 decimal places. So we get the extra 0.2. And then for Bank B, it would be 1 plus 0.023, divided by 360, caret 360. And so it'll be 2.33. Rounded to 2 decimal places. All right, so obviously Bank A is better. You have a higher APY. So Bank A is better because it's greater annual percentage. So D. You can eliminate A and B because the first two answers because it says B is better. Obviously the 2.42% is the higher APY. See, what they're trying to get at here is, does it make a difference for the schedule? Does compounding daily overcome a smaller rate? And the answer is no. Okay, so that was 31. A couple more here. So if you saw this sign, would they be telling the truth? See, they say 4.6 rate compounded quarterly, 4.8% annual percentage yield. That's what banks will do. That's how they advertise. Is there anything wrong with the sign? Well, we can figure it out. It's compounded quarterly, so we just do 1 plus 0.046 divided by 4, caret 4. So we get 4.68. And so, yeah, there is a problem. It's not true. So B, the correct percentage would be 4.68. So somebody in the advertising department forgot the 6. Or changed it to an 8.
Somebody did a little extra rounding.
Yeah.
Math wasn't their strong subject.
I guess they could have got away with saying 4.7, but not 4.8. Okay. And then, see, that was, 36. Suppose you saw an advertisement for a newspaper for a financial planner is recommending a certificate of deposit that pays 3.5% compounded quarterly. In the fine print at the bottom of the advertisement, it stated that the APY on the CD was 3.55. Was the advertisement accurate? So it's the same kind of question. So once again, I just do $1 at 3.5% compounded quarterly, which is 4 compoundings, and I get 3.55. So it's accurate. This one's good. Okay, I think there's a review of a future value. We just go back to the future. Corrine's goal is to have $30,000 to start it. Okay, no, this is a present value. She wants 30 grand down the road. She wants a future value of 30 grand in 17 years. How much should she invest now in a CD that pays 4.75% interest compounded quarterly to reach her goal? So you can make up a scenario like she inherited some money from her parents, and she wants to know how much she can put aside. She's willing to work for the 17 years, but she wants 30 grand when she's done. Regardless of what else happens, she wants to put something aside now and have that. She's got a good percentage there at 4.75%. So using the present value formula, we put 30 grand divided by double parentheses 1 plus R over N, 0.0475. And it's compounded quarterly, so divided by 4, and then it's caret 4 times 14, because it's quarterly, I'm sorry, 17. So there's 68 compoundings total. So she needs to put away $13,442.94. And that'll get her 30 grand in 17 years. Okay, that's kind of a realistic scenario. And this is kind of a realistic one too. It's a little bit involved, but we can do it. A village recently completed the construction of a new water tower. The entire cost of the water tower was $905,000, and the government paid $430,000 of the total cost through the awarding of the grant. So we can answer the first question: what's the balance due? So if we subtract $430,000 from $905,000, they owe $475,000. All right, so that's the balance. And then, in addition, the village can delay paying the balance of that $475,000 for 40 years without paying any interest during the 40 years. So that's a really nice government plan, right? Sounds like a government plan. To finance the balance, the village board will, at this time, assess its 686 homeowners a one-time flat fee surcharge, and then invest the money in a 40-year CD paying 7.2% compounded monthly. So those are good numbers, 7.2%, and no interest from the government. So it's a present value formula. I have to figure out how much they have to invest now, and then I'll divide it up amongst all the homeowners. But to get the present value, we use the present value formula. So they owe $475,000. We divide that by double parentheses 1 plus R, good percentage, 7.2%, and it's compounded monthly, which is even better. And it'll be for 40 years, so that's 12 times 40, 480 compoundings, right? So they need to put aside right now $26,894.46. So I take the 26,894 and 46 cents. I divide by how many people are in the village, 686 currently. So they'll each have to pay $39.20 to pay off the loan or pay off the balance. Okay, something's wrong.
It's asking how much the village needs.
Okay, how much do they need to invest?
So it would be the 26.
Yeah, the 20. I jumped the shark. Wrong. I went to the wrong. Now they want the surcharge. So now it's $39.20. There was 3 parts to it. I jumped.
You jumped the gun there.
Yeah, I jumped the gun. All right. So this is in putting in the second formula, the present value formula. Boy, that's a nice CD paying 7.2%. See, they only have to invest, look at that, to pay off a $475 loan, they only have to invest less than $27,000 today. Of course, it's 40 years down the road. Well, the government will be happy, huh? All right, so that's it for the first section with compound interest and APY. Now we're going to go to installment by section 10.4. Okay, so let's see if we can get some definitions out of the way here. A loan in which you pay a fixed amount of money for a set number of payments is called a fixed installment loan. Installment being the monthly payment. I know it says a set number of payments, and that's in reference to a monthly payment. Okay. A loan on which you make variable payments, this is just a throwaway, just to show you that this is a credit card. It's an open-end installment. Those are credit cards because there's no set amount. There's only a date with a minimum, right? Okay, so credit cards are gone over in the book, but credit cards there's so many different systems. Each credit card company has their own system as long as it falls into line with whatever state laws that they're operating under. So some of them calculate the average interest over the whole span of a month. There's all different kinds, you know. So I don't like to get involved in those because anyway. The true rate of I gave the answer away. The true rate of interest charged for a loan is called the annual percentage rate, APR. That's the true rate, APR. Everything else is advertising. Number 5, is it? Yeah. The sum of all the monthly payments and the down payment, if any. So the monthly payments include principal and interest plus the down payment. All 3 of those combined are the total installment price. Okay. And here we go. Let's start with number 9. Now, I'm going to show you 2 different ways to do this. And the second one is the one I'll recommend to you. The only time we have to use the formula, which is the third formula there, it's the formula for M. So now we got a new letter, M. M is monthly payment. And it's the same formula as down below for, actually it only occurs once. If you look on the front, it occurs twice. It occurs for E and G. And it's the same formula. Whether it's an installment loan or a mortgage, it's the same formula. So M is the monthly payment. All right, so here's how we do this. We'll use the formula first, just to show you that it works. Now, I got to warn you, sometimes there's a discrepancy in the 2 methods. Sometimes they're spot on to the penny. Sometimes they're off by a penny or 2. And that's when that happens is you've all bought stuff on time. Have you ever noticed that the final payment is not always the same as the first 35 or the first whatever? That's because when you add the finance charge to the principal and divide by the number of payments, it doesn't come out evenly. Okay, so as long as you know that. So here we go. The amount financed, so we're going to use this formula M. So I got to open my calculator. And the formula is P times R over N in the numerator. So P is 16,000. We're borrowing $16,000. Times R, which is 0.055, and N is 12. They actually tell us, they remind us that N is 12. So there's my numerator. And I don't need any parentheses because it's all order of operations is all equivalent. And so I divide by parentheses 1 minus parentheses 1 plus R over N. There's our old buddy. 1 plus R is 0.055 divided by 12, which is N. And then caret, and now here's the kicker, it's caret negative NT. So caret negative N is negative 12 times T is 3. So it's negative 36. And so the monthly payment will be $483.13. Let's see if they accept that answer. $483.13. Yes, they accept it. Now, the easier way to do this, believe it or not, is using this table. The top one. The top one is long-term loans with finance charge for $100 of amount financed. The amounts that are in the table are the amount of dollars per $100 of amount financed. And the way we define those is we have to know the APR and the total NT. We have to know the total number of payments and the rate. And that'll give us, and the numbers in the middle we call V. It's the V number. And for clarity, we call it V1, V sub 1. It's the V1 number. So we have a new letter. All right, so how does that work? So they actually give us the tables. You say, this is the same table as you have printed out. Okay, so we know it's 5.5%, so there's my column, and we know it's 12 times 3 is 36, so we go to the row 36. And the number there, can you see it? 8.71. All right, so that's the number of dollars per hundreds. And how many hundreds are there? Well, if you're not sure, you just take the whole amount of P and divide by 100. There's 160 of them. So you could have just times 160, or you could. Now this is nice when there's only zeros, because then all you got to do is drop 2 zeros. But if there was a whole, like 16,375, then it'd be 163.75. So you'd have to take that into. Anyway, this is the finance charge. We just calculated the finance charge. See, finance rate. So that's how much we add to the principal. So we take 16,000 plus $1,393.60, and we divide that by how many payments? By 36. And guess what number we're going to get? 483. See, we get 483.16. So it's 3 cents off.
But wouldn't you get that wrong?
No.
No?
No, because they would accept that also.
Okay, I just want to know.
Yeah, there's enough leeway.
Yeah.
The next one I'll show you.
Okay.
I'll do them both again, but I'll put the table value in.
Okay.
Okay? So a lot of times we do this, they're spot on, but sometimes they're not. So watch this. If I do, see this, it's 17,390.60. If I do, let me write that number down because it might float away. This is the total installment price. Principal plus interest. There's no down payment, so I don't have to add that in, right? There's no down payment. That's the total installment price as we had described earlier. Or when we get to mortgages, we'll call it P&I, principal plus interest. Now, if I do 483.16 times 36, see, I get 16 cents more. If I do 483.13 times 36, the number we put in there, see, I get 92.68, I get a little bit less. So whichever way we reckoned it, the last payment would have to be adjusted.
Right.
One would be less, the other one would be more. It all depends on the finance company you go to and how they figure it out. But they'll always tell you the last payment's slightly different. That's always true.
Right.
Okay. So the next one we're going to do both ways, but I'm going to put the number in that we calculate for the table. Okay, this is 13. Jamie needs a new roof on her house. The cash cost is $5,500. She decides to finance the project by paying 10% down with the balance paid in 18 monthly payments of $288. Oh, let me back up. Let me back up. Yeah, let me back up. Let's do this one. Landon Wallen is an auto mechanic who wishes to start his own business. He will need $4,500 to purchase tools and equipment. He decides to finance a 60-month fixed installment loan with a 6% APR. Okay, so I'll do the formula again first, so you can see. And then I won't input it just to show you, see if it's different or not. So it's P. There's no down payment, so P is the same as the loan. Times R, which is 6%, divided by 12. Divided by parentheses 1 minus parentheses 1 plus R 0.06 divided by 12, caret negative 60. Oops. Negative 60. All right, so $87 even. Now we'll use the formula, or we'll use the table. All right, so we cross, this time I won't open it up, we'll do it together from our handout. We got to go to 6% and go down to the bottom row, and you get 16. 16 flat, you see it? So I take 16 times 45, that's 4,500. That's this finance charge, so I add that to the 4,500. There's the installment loan price, and I divide by 60, and we get $87. This time they're spot on, they agree.
Right.
Although you see, this one calculated to exactly 87, this one rounds up to 87 because of the decimal. But they both agree this time. And sometimes that happens. Okay, so $87. Oh, they want the finance charge. I answered the wrong question. The finance charge is $720. The monthly payment's $87. Once again, I jumped the gun. I'm thinking about the next problem. Okay, we're good with that one, right? All right. So now they're gonna set us up for finding the percent given that we know everything else. And basically what that is finding V1. Because if you find V1, then you can find the percent. So it's these two formulas that I added to the bottom. I'll show you how that works. All right, so Jamie needs a new roof. The cost is $5,200. She decides to pay 18% down. See how the numbers changed from the last time I opened this? Okay, with the balance paid in 12 monthly payments of $368. All right, so they're telling us how much she paid total installment. But before we do that, we have to know how much she really borrowed. Because she didn't borrow $5,200. She borrowed 82%. She paid 18% down.
Right.
So if I take 82% times 5,200, that's what she borrowed. She borrowed 4,264, and she paid off 368 times 12. So the difference is 416 minus 4264. Her finance charge was $152. So I have to figure out how many hundredths there were. So I take 152. This is where I will divide by 42.64. In other words, 4264. I got to be careful here. I better use 4264. That's the total principal that you borrow divided by 100. Or you could just move the decimal place over. So the V is 3.56. So I opened it up here so you can see what I'm going to do. Well, first of all, they want the finance charge. So let me answer that one. 152. Okay, so now they want the APR. So we know which row we're in. We're in row 12, and we just go along until we find a 3.56 or something real close. Oh, there it is. It's right on the money. So 6.5%. See how we work backwards? And what I really did, I kind of used this formula. See, because we took 12 times m times t. T is 1, so we did 12 times m, which was the 4416. We subtracted the 4264, and it's the same formula we did in the calculator, only it's already inverted. That's why the 100 is upstairs. See, that 100 came up. There's the difference times 100 divided by that. It's just, instead of having a complex fraction, so instead of having t over 100 in the denominator, the 100 came up to the numerator. Anyway, 3.56 means the annual rate 6.5%. Now, the reason we need to do this like this is because we're going to have installment loans that people want to pay off early. And so we will know the original V. Let's say it was a 36-month loan at 6%, and this was our V, and then they're going to want to know how much do they save in interest if they pay it off after 24 months. So we have to float up. We have to know which column we're in so we can float up and get a new V to solve for the unearned interest, right? Because the way these are set up, you pay a flat rate each month, but it's not equalized between principal and interest. It's heavily loaded on interest up front. Because if you use the simple interest formula on a monthly basis, it's more at the beginning because it goes down because the principal goes down as you pay it off. And so it looks like it's a flat rate P&I, but the amount of interest, like I said, it gets less as you go. You'll see that true. If you ever seen them, you guys know what amortization schedules are for a mortgage? You ever seen a mortgage schedule? Have you ever bought a house? Okay. When you buy a house, and I'll show you, that'll be on Thursday. You get an amortization schedule. It shows you all 360 payments. It shows you what you pay each month flat rate. Then it shows you how much is principal, how much is interest, and how much the balance is. And up front, the first month is like almost all interest. You know, if you're paying $1,000 a month, it's probably $900 interest. Then the next month it's $897, and then it's $894, and it keeps going down, but you're paying a lot of interest up front because if you did the simple interest formula, I equals PRT, it's heavily loaded at the front because it's all interest, because the P is so large. Anyway, that's what we're going to need to know this for going forward here. I think we have another one like this where yeah, this one's straightforward too. Jack Fitzgerald wishes to purchase a used car that has a cash price of $11,000. Installment terms include a down payment of $4,000 and 36 monthly payments of $224. So he only borrowed $7,000. So I take the $224, monthly payments, times 36, and I subtract $7,000 because that's the principal. So the finance charge is $1,064. Is that too fast? Okay, so he pays, that's his finance charge. Now they want to know the APR. Well, if he borrowed 7,000, I just divide this by 7 because that's 7,100. So 15.2 in the 36th row. It's, the closest one is the last one, 15.32. So we round it to 9.5%. Given this table, that's the best we can do. Let's see if our table's any different. 15.32. It's the same table. All right, so we're close enough. If you end up, I hope you don't end up midway between two numbers. Always pick the one that you're closest to. So these two last ones were helping us to have to figure out how to find the APR because they're gonna mess with us now. Here we go. Ray Flagg took out a 60-month fixed installment loan of $12,000 to open a new pet store. No money down, so the $12,000 is the principal. He began making monthly payments of $232 every month. Ray's business does better than expected, and instead of making the 24th payment, Ray wishes to repay his loan in full. Okay, so first thing we need to do is find the APR. So to do that, we first take the monthly payment of $232 times 60. That's the total installment price, and I subtract the principal of $12,000. I get the finance charge of $19.20. I then divide that by the number of hundreds, which is 120. In 12,000, there's 120 hundredths. So my V1 is 16. And I need to go to the row with 60, because my V1 is for 60, and it's 6%. You see that?
Where did, I think you lost me after 60. Oh, 61. Okay, thank you.
See, there's the 60 months, so it's 16. So you go up to get 66%. See, before we were taking these two numbers and coming down.
Yeah.
Now we're solving for this number, and we know which row we're in. So now we have to figure out which column. And the reason for that is because if he's going to make a payment after 24 months, that means he has 36 months left. So when I solve for his interest, I have to use this number, 9.5. So the interest, unearned interest formula is in F. And you can see it's another new letter, U. So V1 is the amount of finance charge per 100, and U is the unearned unearned interest. The bank can't charge you interest for 60 months if you only use it for 24 months. So they have to give you back interest. And U is equal to, and I don't know if it's on yours or not, but it should be, N is the number of months remaining. This is a different N than this. And M, we know, is the monthly payment. And then V2. V2 is the new V. The original V, that's why I call it V1. It's the original amount is 16, and then 100 plus V2. It's a pretty straight formula, and you don't really need parentheses. So the new V2 is 9.52 because there's 36 months left on his loan. He started at 60. After 24 months, there'd be 36 months left. So to find the unearned interest, I take N, which is 36, times M was $232 a month payment, times V2, which is 9.52, divided by 100 plus that, so it's 109.52. And so the unearned interest is $725, or $726. First of all, I got to answer this. It was 6%, wasn't it? Okay. How much interest will he save? $725, $26.00. So now they want to know what's his final amount for his loan. Well, he's gotta pay 36 more months plus the 24th month, so it's 37 months. So he pays 37 times 232. Oops, 232. But he gets a rebate of the $726 interest. So his final payment's 7,858. And no cents. Have you ever paid off a loan early? No?
I'm trying to do it in the car. Yeah, it's my only payment.
And you have to ask the bank how much on a certain date. They usually give you a window of 2 or 3 days, 4 days. They'll say if you pay it off by this date, this is what you owe. Because they've already figured out the unearned interest for you. But if you don't believe them, you can try to do it yourself now if you have all of it. Just remember, it'll seem like you're paying more than you should, but interest is. Let me show you. It's $232, right, for the first month payment? Or all of them, but the first month's $232. How much of that is interest? Well, if I just take the principal, P equals I times R times T, so it's 0.06 divided by 12. 1/12 is 1 month. See, $60 interest on the first month. That's not too bad, really. But 60 times 60 is 3,600, and the finance charge wasn't near that amount, was it? It was 1,000 and something. I forget, what was it? I forget. That's a different problem. But see, okay, because the second month, if it's $60 on the first month, if I take 232 minus 60, then the principal is lessened by 172. So I would take 12,000 minus 172. That's my new principal, times 0.06 divided by 12, one for the next month. The next month the interest is $59.14. But I get an extra 86 cents principal. So it's going to keep going down. That's why it seems like, well, only $726. Well, that's the nature of how these things work. It's all simple interest formula. All right, let's do the next one, 18. Jez Leanne has a 36-month installment loan with a fixed monthly payment of $101.14. The amount she borrowed was $3,400, so that's the principal. Instead of making her sixth payment, Jez Leanne is paying off the remaining balance of the loan. Okay, what's the APR? Okay, so once again, we need to know the finance charge. So she has 36 times 101.14, and she borrowed $3,400. So it's $241.04. And I take $241.04 and divide by the number of hundreds, which was, how much did she borrow?
34.
So divided by 34. So 709. And you see, if you go to the 36th row, there is 709. 4.5%. 4.5%. And how much interest will she save? Okay, so if it's 6 months, that means there's 30 months left. So N is 30 for that formula, the U formula, and the monthly payment was 101.14. And the new V, you just go up to the 30 row, because she started with 36. After 6 months, there's 30 left, so 5.92. So it'll be 5.92 and divided by 105.92. So she's.
So we say $16?
Why 105.92?
Yeah.
I did something wrong, didn't I?
No, you put 11.
Yep. But divided by 105. 96.
What did I do wrong? Oh, I did 1105.
Uh-huh.
There's a double, 2 ones in there. I see it now. So 169.59.
That makes it a little more sense.
I was like, $16? I'm not paying you nothing for $16.
For some reason, I have heavy thumbs or something.
It happens.
So the payoff amount, so there's 31 payments, because she has the 30 plus the 6 payment, so 31 times the 101.14, but you subtract the 169 and 59 cents. So she'll pay $2,965 and 75 cents. Any questions about that one?
Yep.
Those last two were pretty much similar, weren't they? Just, you can see now where V1 and V2, why they make sense that way. That was 18. Yeah, there's only one more problem, that's why. 19. Let's see what it says. Nina buys a new sports vehicle for $32,000. She trades in her old truck and receives $11,000, which she uses as a down payment. So she only really borrowed $21,000. She finances the balance of 5% over 36 months. Before making her 6th payment, she decides to pay off the loan. Okay, so this is real similar then. Only now we know everything. Using the given table, determine the total interest Nina would pay if all 36 months payments were made. Okay, so I need to know what the monthly payment was. So this time I got to go to 36 and 5%, so 7.9. So that's the amount finance charge per 100, and there's 21,000, so that's 210 hundredths. So the total finance charge is $1,659 plus the 21,000 divided by 36. So the monthly payment is $629.42. I need M to solve the formula. All right, so now they want to know the total interest. So that's $1,659. Let me answer that question. Now, what we're needless. Okay, now monthly payments, $629.42. Okay, how much interest will she save? So now there's 30 payments left. So the N is 30. Her monthly payment $629.42, and I need V2. V1 was $790. Got to go up to the 30 because there's 30 months left. So that's 6.59 divided by 106.59. So she's going to.
You did it again with the one.
Yeah, you double the ones up.
Yep.
I just noticed that. Thank you. You see, I hesitated. So 1,167 and 43. Okay. And what's your final payment? Well, her final payment is 31 times the monthly of 629.42 minus 1167.43. So she's going to pay off 18,344.59 cents. Yeah, I did pretty good today. Except for my double ones there. All right, so that's it for the installment loans. You can see that we didn't use the formula. We used the table almost exclusively. And you're going to see that the same thing's going to be true in mortgages, only it's a different kind of table, slightly different. But the only time we would have to use the formula is if the number of years or the percentage were not on there. So if we have if we didn't have the percentage or the number of payments, we would have to use the formula. Now you can imagine that banks, they have books, they have like for every possible percentage to 2 or 3 decimal places, you know? And the number of months probably to the exact, each month, if you want it for 87 months, they could probably give it to you for that, you know? They probably don't like to do that, but if they want you as a customer, they'll do whatever it takes. So. But anyway, we have a very abbreviated tables. Neither one of you bought a house then?
No, no, not yet.
Okay.
But
Well,
it's
well, that'll be
actually easier.
Thursday. We'll talk about those on Thursday.
Cool.
Are there any questions for what we did today though?
Yeah.
That's good to go, huh?
Yeah.
All right, so you're good for homework 7. And everything's, I don't see any problems, so, but make sure you keep in touch with me if anything comes up.
Okay.
All right?
Well, we'll see you Thursday, yeah?
Yes, ma'am, Thursday.
Yeah, when I say now, test 2 by tomorrow.
Okay, I think, did I get you up in the 90s with raising your score there? I think I did, didn't I?
For which one?
For the homework. Did you remember?
Yeah, I think so.
All right, that was my attempt. Let's see if I did. Yeah.
Yep.
All right.
Thank you.
Yes, ma'am.
I appreciate that so much.
Okay. We are good to go. I better shut this down.